Have you ever wondered how our blood circulates all throughout our body? What would happen if blood, especially the oxygen-rich blood, doesn't circulate? Have you ever asked yourself, how do oxygen and nutrients get distributed all throughout my body? Is it just with the help of respiratory system and digestive system? Are you familiar with systemic and pulmonary circuit? How about their differences? If you'd like to know the answers for these, this video is for you. I am RJ D. Guzman, a first-year psych student, your guide to your journey to the circulatory system. According to Encyclopedia Britannica, circulatory system is a system that transports nutrients, respiratory gases, and metabolic products throughout a living organism, permitting integration among the various tissues. Circulatory system is made up of blood vessels, arteries, veins, heart, blood, capillaries, arterioles, and venules. Now that you already know what a circulatory system is and what it is made up of, let's now talk about its importance. Circulatory system is important in sustaining life because it is responsible for the circulation of blood, delivery of oxygen and nutrients to all cells, including the removal of carbon dioxide and waste products. Also, it acts upon the maintenance of optimum pH and mobility of elements, proteins, and cells of the immune system. Let's go back to the question, how do blood circulate all throughout our body? The first thing that happens is the right ventricle pumps the oxygen-poor blood to the lungs through the pulmonary valve. The left atrium receives the oxygen-rich blood and pumps it to the left ventricle through the mitral valve. And finally, left ventricle pumps oxygen-rich blood through the aortic valve out to the rest of the body. The sequence of the heartbeat is referred to as cardiac cycle, and it has 4 stages: the filling phase, the isovolumetric contraction, outflow phase, and isovolumetric relaxation. The first thing that happens in this cycle is the filling phase, wherein the ventricles fill during the diastole and atrial systole. It is followed by isovolumetric contraction, wherein ventricles contract, building up of pressure ready to pump blood into the aorta or pulmonary trunk. The next stage that happens is the outflow phase, wherein the ventricles continue to contract, pushing the blood into the aorta and in the pulmonary trunk. It is followed by isovolumetric relaxation, wherein the ventricles relax, ready to refill with blood in the next filling. And the process starts again from the first stage and continues and so on. There are 5 conduction systems of the heart. The first one is the sinoatrial node, or the pacemaker of the heart. Next is the atrioventricular node, or the node of Tolera. And then, atrioventricular bundle of His is also a conduction system of the heart, including the right and left branches of the bundle of His. And lastly, the subendocardial Purkinje fibers. What you heard in that clip is the heart sound. The lub sound, or S1, is the result of the closing of the AV valves after the atria pump blood into the ventricles. On the other hand, the dub sound, or the S2, originates from the closing of aortic and pulmonary valves after the ventricles have ejected blood. However, if a person has a heart disease, heart murmurs will be heard instead of the lub-dub sound. Let's proceed to the systemic and pulmonary circuit. Systemic circulation moves blood between the heart and the rest of the body. It sends oxygenated blood out to the cells and returns the oxygenated blood to the heart. Pulmonary circulation, on the other hand, moves blood between the heart and the lungs. It transports the oxygenated blood to the lungs to absorb oxygen and release carbon dioxide. The oxygenated blood then flows back to the heart. And that's Circulatory System. Again, I am RJ D. Guzman, your guide to your journey to the circulatory system. See you to your next journey.